Welcome to my YouTube channel. Hello everyone, I am Precious Ugweze. In this video, we'll quickly look at this problem here under sum and product of roots. It says find k so that the roots of the equation here will have the same sign. Okay, so that is to say, for what value of k are we going to have roots for this? Remember, this is a quadratic equation. For the quadratic roots for this equation to have the same sign, whether positive, positive, or negative, negative. Okay, so what are we going to have? Now, if the roots are alpha and beta, if they are going to have the same sign, the implication is that if you multiply the two of them, you should get a positive number. And so you are supposed to have a number that is positive, that's greater than 0. So if they have the same sign, whether negative, negative, negative times negative will give you positive. Whether positive, positive, it will still give you positive. So this condition must be satisfied if the two roots, alpha and beta, will have the same sign. Okay, you remember that we said that the product of the roots of any equation, if you have alpha beta, is equal to c all over a. All right, and then if you come into this equation, from this equation, our a is simply equal to 1, and our c is this particular term here. Okay, so the whole of this is our c, our a is 1, and our b is the whole of this. That's negative 3k plus 1. All right, so we'll quickly substitute into this equation. Okay, this is k squared minus k minus 2. Okay, the product, which is alpha beta, is equal to k squared minus k minus 2 all over 1, which is the same. That this must be greater than 0. All right, and so we need to solve this inequality and then find the value of k that satisfies it, and that's the same value of k that will give us roots of the same sign. All right, and then, so we go ahead to solve that, and so that's going to give us k squared minus k minus 2 is greater than 0. To factorize this, we are going to have the coefficient here is 1 minus 2. That's going to give us minus 2. So the two factors of this that will give us negative 1 will be minus 2 and positive 1. And so we can substitute that here. That will give us minus 2k plus k minus 2 is greater than 0. And so if we come over to this side, that's going to give us, if we factorize these two now, or put them into two brackets, here we are going to have k into k minus 2, and over here you will have 1 into k minus 2, and all of this greater than 0. So here you will have k minus 2 into k plus 1 is greater than 0. So, and for you to have this to be greater than 0, if you watch my previous video, you will see where I said for this to be greater than 0. So the meaning is that that k minus 2 is greater than 0, and k plus 1 is greater than 0, or k minus 2 is less than 0 and k plus 1 is also less than 0. If any of these two happens, then you are going to get that the product is greater than 0. And so for that to happen, we'll simplify here. And if we do that, from the first part here, this is 1, this is 2. From the first part here, we'll get that k is greater than 0, greater than 2. So we have that k is greater than 2 and k is greater than minus 1. Or from the second one, we'll have that k is less than 2 and k is also less than minus 1. Okay, so from here, can we get a range that is going to satisfy the requirement that we have? So from here, what you will get is that if you join the two here, if k is greater than 2 and greater than minus 1. Of course, minus 1 is less than 2. So anything greater than 2 is also greater than minus 1. So we take just the first one here. K is greater than 2. And then down this way, you can see here that k is less than 2 and k is less than minus 1. So 2 is greater than minus 1, and so anything that is less than minus 1 would definitely be less than 2, and so we take k is less than minus 1 here. So if you join the two, let's come over here, you discover that the solution to this problem is that our k has to be less than minus 1, or our k must be greater than 2. Okay, so anything that falls out of this range here is not going to satisfy this equation to give us the same sign for the roots. You can check it. You can check now. If k is greater than minus, if you put this graphically on a number line, what it means is that on a number line from minus 1 down is the value of our k, and then from 2 up is the value of our k. So anything in between this space is not going to satisfy this equation to give us what we want. An example of something here is 0, an example of something here is 1, and if you put any of them here, you are not going to get the same sign if you solve the quadratic equation you obtain. For instance, if we put k as 1 here, this is going to give us 3 plus 1, which is 4. So we're going to have x squared. Let me bring it down here. So we're going to have x squared minus 4x. If we put 1 here, we're going to get 1 squared is 1, minus 1 is 0, and so you have minus 2 here, equal to 0. If you solve this quadratic equation, you are not going to get roots of the same sign. So you can try that. And if you put 0 as well, it will also give you a quadratic equation whose roots are not going to have the same sign. But if you pick any other number that is less than -1 or greater than 2 from numbers like 3, 4, and all that, and put them here, you are going to definitely get a quadratic equation whose roots are going to have the same sign, either both negative or both positive. Okay, and that's the solution to the problem we are given. And that's where we're going to stop this for today's class. And please kindly subscribe to our YouTube channel, click the thumbs up, and then share our video, make comments, and then we'll see you in our next class. Thanks for watching. Bye.